Okay, Assalamualaikum warahmatullahi wabarakatuh. This is the lecture for chapter 3, and this part is theory. So we try to do this. Whatever you want to understand for this lecture is actually stated in the lecture slide. So this is the simplified way for you to understand all the theory. So we will divide the explanation into 1, 2, 3, 4. Explanation, the first one is you need to know what is shear strength of soil. And basically when we ask this question, it is to understand what is the dominant parameter for our soil to consider as its strength. And then afterwards, we will explain about definition of total stress, effective stress, and pore water pressure. Okay, this is very important part because we will differentiate into two terminologies, which is total stress and effective stress. Two of these stresses have a very distinctive differences, so you need to understand both of these parameter for us to proceed to calculate for shear strength. And the last part will be the third part will be important of effective stress. Okay, why this is very important in uh, in our soil mechanics, and the last one will be the shear strength of the soil. So let's begin with what is shear strength of soil. Okay, basically we understand every material in this world, it has the limit. Okay, when you put stress or you put pressure on any material, at one point it will break or rupture or fail, what we call it as fail. And so does soil mechanics, and in soil we explain into the shear. Okay, this is the dominant factor because in soil, okay, what is usually happen is you have soil on the top of any building. Okay, let's say this is will be your building, and this building will put very huge load below your soil. And when this is referred to laboratory session, we simulate the same situation. So this is the load from your building. Okay, what will happen is we have the failure in terms of shearing force rather than compression and tensile. So it is the more dominant into shear. So what is explained in soil strength we describe under shear strength, and it will determine by the strength parameter, which is C, phi, C dash and phi dash. Okay, we will look into this further on. And next, okay, this is what you need to understand for total stress, effective stress, and also pore water pressure. And for total stress, it is whatever you have on site. Okay, let's say, okay, this is your soil, and then we want to consider what will be the stress value for this particle of soil. Okay, if this is the situation, what will be the stress that will be experienced by this particle? Okay, we name this particle A. Or if you want to visualize more, let's say A is U. So what happened? What is the pressure that you will experience for this particular total stress explanation? Okay, let's look into how to simulate this one. Okay, let's say this is the situation, the same situation, and we want to consider the the stress experienced by A, or whatever we have discussed earlier. Let's say this is U. So what is actually the stress experienced by this particle? Okay, before we can explain what will be experienced by this particle, okay, we must know that the characteristic or the parameter of our soil we have in terms of gamma. This one is, we call it as unit weight. Okay, this is the density of the soil. So that one is the unit weight of the soil. So in this case, what you have is, we want to consider this. Okay, and then we want to analyze under total stress analysis. Total stress analysis meaning that you have point, and whatever on the top of that point, okay, either inside the ground or outside the ground, you will consider all the load that will be acted on this point. So if you have water inside here, or you have building around here, so every stress will be acted on this point, we will consider it as stress will be acted on this point. So in this scenario, okay, what you have is you have points and you don't have anything else. And then because of we have gamma, and then we have the point that this stress will have is from this height to this height, from ground to this point, that will be the H. So what we will experience by that point is stress is equal to gamma H. Okay, gamma is the unit weight of the soil as mentioned earlier, and H will be the height of the soil. So at this point, because you don't have anything else, the stress experienced by that particle or soil particle is gamma H. And this stress is in the unit of kilonewton per n squared. So this one is unit stress. Okay, what happens if you have the case of, okay, your soil here is flooded with water. So you have a groundwater table, and this groundwater table is go up to the ground level, and we still want to consider what will be the stress experienced by this particle. At this condition, okay, we have water. The unit weight of water is gamma W, and then this soil we experience the weight of water from ground to this point. At the same time, okay, this whole area has been flooded with water, so the soil at this area is fully saturated soil. Okay, in this case, okay, you still need to ask the question, what will be the stress experienced for that particle at that point. So now, okay, whatever load will be acted on the soil, we will consider or we calculate under total stress analysis. So at that point, okay, you have stress. That soil will experience the stress from water. That one is gamma water, and that gamma water will be acted using the height from ground to the point that we want to consider, plus unit weight of soil, which is already saturated, and that unit weight must be times with the height of the soil. So that is the case if you have your soil and then the whole area is flooded with groundwater table. So what happened if now you still need to consider the particle here, and then at the same time we have building on the top of your soil layer, and that building we consider is as the load Q. We usually explain the load from building or whatever structure that you constructed on the top of your soil, that one we consider as surcharge load, and the notation of surcharge load is Q. So right now the same question will be asked, if we are considering total stress analysis, what will be experienced by that particle at the height H. So at that point, your soil experience the load from the structure, which is Q, and then because you have also, this is all soil, will also acted on this point, there will be unit weight of soil, you multiply by H. So that is the consideration of total stress analysis. If you see in the lecture slide, it explains about 3 types of loading acted on the particle soil, and you must know when we discuss about total analysis, this is what we should explain. So that is about total stress analysis. And then next, we need to consider the explanation about effective stress and pore water pressure. But before that, before we discuss about pore water pressure, effective stress, we should discuss about pore water pressure. Alright, consider your soil. Okay, we already explained about soil at the beginning of your semester. Okay, you know that under 3-phase diagram, okay, this will be your soil, and inside your soil you have solid particle or soil particle, and then those who are not occupied by your soil, that one we call as void. Okay, this particle we call is as soil solid, and we know that this void can be either from your water or air, right? So it can be occupied by water, and most of the soil void will be occupied by water if it happened that your groundwater table is up there, so that one will be occupied by water. And at the same time, okay, let's say there's more water here. Okay, at the same time, you still see that there is some of the space is not occupied by water, and that one is occupied by air ataupun udara lah. So, okay, consider this is your soil particle, and then we know that inside the soil particle we have solid soil, solid as the soil particle, and then we have void, and this void is not occupied with water, and what occupied inside here is pore, or what we call as air. And okay, let's say the same situation that we have load on the top of your soil sample here. Okay, when we have action, there will be counter action when you put on the top of your soil with load. Okay, this soil will acted back to push the load, to counter the load, and then at the same time, this void and occupied by pressure, pore water pressure, pore pressure will be also acted to counter whatever stress acted on your soil. So, okay, you have the solid to counter the action here, and then you have pore pressure to counter forces acted, the external forces acted. So that pore water pressure or pore pressure we consider as delta U. So right now you have the explanation about total stress, and then you have the explanation about pore water pressure, and what is the effective stress. Okay, okay, we have a very strong reason why we introduce total stress first, and then we introduce pore water pressure later. Total stress is whatever acted on the top of your soil, and during the total stress, we still have pore water pressure inside your soil, and then that pore will be acted to counter that action. And then, okay, how to explain effective stress? Okay, effective stress is the effective stress is the condition. Okay, when you have, effective stress is the condition is that, okay, when you have your soil already being compressed, and every particle inside your soil has been arranged so compact, there is no space for pore to be inserted in that structure. Okay, in this composition, there is no more pore. Okay, there is no more water, there is no more pressure. So for total stress analysis, because we have excluded the effect of pore, so your stress analysis later on will use this expression, which is total stress minus pore water pressure. So that is the three conditions that we can explain under different situation of total stress, effective stress, and pore water pressure. So to simplify, okay, if you are considered under total stress analysis, okay, when there is any forces acted on your soil, okay, because the structure is not compacted, you have solid, at the same time all the spaces occupied by pore water. So this is the condition of total stress. And then, okay, because of circumstances that due time, okay, when you load this one, eventually the water inside the void will come out. Okay, that is the norm. That will be what is actually happen on site. Okay, when all the water have drained out from this soil, okay, it will be arranged the new structure, which is more compact, and there is no water or pore water pressure inside your soil structure. And if we are consider everything is only soil solid, that one we consider under the analysis of effective stress, and that one we will use the expression of stress dash equal to total stress minus pore water pressure. Okay, meaning that effective stress is we exclude pore water pressure, and we do understand that for effective stress, all that acted during effective stress is the soil grain only. We are not including anything from the pore water pressure. So, of course, at that point, okay, at this point, you must know about that three things, and then we must move on. Okay, next we are considering why we need to understand about the effective stress or the importance of effective stress. Okay, the importance of effective stress. Effective stress is when we consider the strength without pore water pressure. So we must remember this one. Okay, this is the actual what happened on site. Okay, what we want on site is we consider the strength value due to effective stress. So we know exactly what is the strength of the soil in the perspective of shear stress. So with this, you can calculate what is the shear strength value, and then from the effective stress analysis, we can calculate about the bearing capacity of soil. Bearing capacity is okay, how much burden that your soil can retain. If you put any load on the top of your soil, okay, how much the soil can withstand, that is what we call as bearing capacity. Shear strength is more in terms of this internal strength of the soil. And then from that one, you can calculate for slope stability, and then you also can calculate for settlement in terms of the value of settlement. Settlement is the value of soil that will settle. Okay, how to describe settlement? Okay, this is settlement. Yeah, you have your soil, and then you put your building. Okay, because we know that you have solid and you have pore water pressure inside there. Over time, all the water will drain out, and then only soil will retain there, no more pore water pressure. So this measurement, this measurement from this point to this point, we call it as settlement, or in Malay we call it as mendapan lah. Okay, itu adalah settlement, and then we can know what is the value of settlement. And of course, in terms of settlement calculation, we also can calculate how much time taken to the settlement occur and the end of the settlement. So we can forecast when the settlement will end. So the last part will be the shear strength. Okay, this is what we will focus on, the calculation. You will focus on shear strength, calculation and analysis. Okay, next section afterwards, if we want to consider about shear strength, okay, we always draw what we call as Mohs circle. And that Mohs circle, of course, require you to use your protractor, all the drawing equipment, we must use that. But before we use the equipment for analysis, we need to understand what are the features of shear strength if we present the shear strength in terms of graphical presentation. Okay, let's say, okay, at the end of your, okay, exactly how to get shear strength, we can do tests, what we call as shear bulk test. And then of course we can also calculate shear strength from triaxial test, but this one is other. Okay, we will discuss about these two tests during lab session in another time. So afterwards, after you have done, either you do your shear bulk test or you do your triaxial test. Okay, at the end you get the data, you calculate the data, and then we will present the data using this graphical presentation. So this is normally what we get for cohesion friction type of soil. Okay, what I want to show you that we have the axis of y and then we have the axis of x. The y-axis is represented by shear and the x-axis represented by stress value. Shear is the unit kilonewton per m squared, and stress also the unit is kilonewton per m squared. Okay, normally we get this relationship. Okay, you have this straight line from your Mohs circle. You can draw this straight line, and this straight line we call it as failure envelope. And after you get this line, you can use your equipment and then you can measure this angle. This is what we call as friction angle, and this friction angle is denoted by phi. And then of course at the same time, this line will cross the y-axis line, and then we denote it by this intersection as C. That one we call as cohesion value. So if you consider this is mathematics, so we can come out with the mathematical expression, which is shear is equal to C plus stress tangent phi. So this is just a matter of mathematics. If mathematics you have C plus mx, right? So that is mx, mm is your kecerunan, something like that. So you can actually relate to your mathematics lesson. So this is the expression for total stress, and for total stress, this is the expression. But for effective stress, the expression is replaced by C dash plus stress dash plus tangent phi dash. So the ultimate calculation for shear strength in this topic chapter 3 is you need to find this one, the friction angle, and then you need to find this one, the C, and then we can left the expression into this expression of shear is equal to C plus stress tangent phi. So that is the introduction for graph that you will produce afterwards. And before we end of this lecture for theory part, okay, you must also need to know about the different types of expression. Okay, even though I show you the general graph that will be we can get from the results, but we have three types of different expression. So if you have your failure envelope, okay, across the zero value here, okay, we know that this will be cohesionless soil. Okay, meaning that cohesionless soil is kind of sand and gravel type of soil. And then of course what is considered here is only the value of phi without any value of c. The c value is 0. And then if you have these types of expression, okay, this is the c value, this is the characteristic of pure cohesive soil. Okay, the type of cohesive soil is clay. And then the parameter strength of you want to find is c, and the value of phi is equal to 0. Okay, the last expression will be cohesive frictional soil, and in this case it has both characteristic, which is the characteristic of cohesionless soil and the characteristic of pure cohesive soil. So as the same explanation, if you get this kind of graph, you will find the value of friction there, and then you can find the value of cohesion there. So you can get the shear strength parameter, which is C and P. So that will be the part of lecture for theoretical part. So if you want to guide yourself to understand the whole explanation about the theoretical part, so you can guide yourself, try to ask, okay, what is shear strength of soil, okay, what is the differences between total stress, effective stress, and pore water pressure, and then okay, why we need to calculate about for effective stress, and why the effective stress is so important, because from the effective stress we can get all of these very important information for engineering decision. And the last part, okay, this will be, we will do this a lot, and this is the shear strength characteristic that you must find in terms of C and also phi value. Okay, for that, this will be the first chapter of the first introduction for chapter 3, and thank you.